Alright, in this video we're going to look at the last little bit of chapter 5.4. So this is estimating turning points, the coordinates of the turning points. Now over the last few chapters we've been drawing and sketching graphs, and what we've done is we've kind of ignored what the coordinates of the turning points are. Sometimes we can find them easily, especially with quadratics, where we find it halfway between the two intercepts, but with cubics and quartics we've kind of ignored what the actual position of them are. And that's okay, because later on we haven't gone into how we're going to do it, because that's a whole unit on itself. We'll be doing that later on, actually finding the coordinates of them and locating them. And that's in calculus, what we call calculus. Now, for the time being, until we get into that, we have to start approximating the coordinates of the turning point by, I guess, through systematic trial and error. So this is I guess, a bit of an extension on the bisection method, almost. So what we can say is, for any polynomial with zeros at x equals a and x equals b, its graph will have at least one turning point between a and b. To illustrate, consider the graph y equals x plus 2, x take 1, x take 4. So the factors show there are three x-intercepts, one at minus 2, a second at 1, and a third at 4. So let's draw that. Y equals x plus 2, x take 1, and x take 4. Okay, if I put that on a set of axes, this one I don't have to be as accurate as I was in the last video. So minus 2, it's roughly about there. Positive 1, it's about there. And positive 4, we'll say is there. Now we've got a cubic because there's three x's and it's positive, so we're going to start from the bottom and move up. So when we draw them, okay, that's about all we were looking at, and we generally find the y-intercept as well, which would be about positive 8. Okay, and then from there, that's generally what we leave it as when we were sketching them. Okay, so finding the x-intercepts and finding the y-intercept. We also, when we draw graphs, we do want to actually calculate the turning points. As I said, we don't know how to do that accurately yet, but we can start estimating. And that's through, I guess, systematic trial and error, as I illustrated before. So the factors show there are three x-intercepts. There would be a turning point between minus 2 and 1, as we can see, minus 2 and 1. There would be a turning point there, which is up here. And a second turning point between 1 and 4, which is down here. The first turning point must be a maximum, and the second one must be a minimum, in order to satisfy the long-term behavior requirements of the positive cubic polynomial. As I said, we've got a positive cubic polynomial because they're all positives, so we start from the bottom. If we start from the bottom, the first one has to be a maximum turning point. The second one would have to be a minimum turning point, as we can see here. So we've got a maximum here and a positive minimum there. Now, if this equation was negative, it would be the other way around. Let's just assume, and I'll illustrate it just for sakes. So negative, okay, this will be in blue, so it would be starting from the top and going down. So similar situation, it's just that we have the opposite. So the first one would always be a minimum turning point, the second one would be a maximum turning point. Okay, so how do we find the coordinates of those turning point? Well, the interval in which the coordinate of the maximum turning point can be narrowed using table of values. So going back to table of values, now this would be in probably year 8, I guess. Going back a while, pretty straightforward. So minus 2, Now I'm going to go down in about 0.5s, 0. Okay, so -2 to 1, I'm going to stop there. So -2 to 1. And then we just work out what the y values of those are. So at 2, or -2, what's our y value? Sub it in. Okay, so -2 plus 2 is 0, so it's going to be 0. Next one, x equals -1.5, so -1.5 plus 2, -1.5 take 1, -1.5 take 4. So doing that, and then you multiply them all together, you should get 6.875. Okay, calculator might be handy there. And same thing for here, I'm just going to fill out the rest. We do the same thing, just sub that value in. So we'll get 10, 10.125, we'll get 8 here, 4.375, and should get 0 there. So we get the zeros at the ends because that's where our turning points are. X-intercepts are. So that's a good thing to check that works. So as a first approximation, the maximum turning point lies near the point -0.5 and 0. No, sorry. It lies somewhere around the -0.5, because we get at this point here we can estimate as -0.5, and we get 10.125 because it's our maximum part there. So that's the maximum point there. All the rest are below 10. So it's going to be between -0.5 and 0, we assume, because that next number is 8, it goes down. So somewhere between those 2 points. So if we zoom in further, let's make a new table. So we say x and y. So let's get a bit more accurate this time. So we'll start at, we'll go half of that again on either side. So 0.75 and 0.5, and these are all negatives, and negative 0.25. Okay, so a little bit either side of that, and this number here is 10.125. So to the left of it, let's see, do we get any more closer or a higher number than this? Putting in your calculator, this into this equation, we get 10.390625. Let's put lots of decimals there. And this side, we should get a lower number, 9.2989, because this number is larger than this number. So we've actually estimated even more accurate, because this number here is greater than this number here. So at the moment, our best accurate estimation is -0.75, and we get a maximum point at 10.390625. Okay, the best we can do at the moment. Now we could go even further either side of that, and we might get an even more accurate answer, but at the moment we'll just leave it like that. And we do the same thing for the minimum turning point. I won't draw the table of values, but you draw one between 1 and 4, so it'd be 1 to 4. Find out where your lowest number would be this time. Okay, so you might find that it's about 2. So then you would check either side of 2 and see if you get even lower number than that. And that would be your estimation for the lower turning point. So we can say when we draw it, okay, we want to use our turning point. So in here we would put this number